Hello and welcome back to project number 4 with Dr. Osborne. My name is Thomas Karbowski. So first thing first we're going to do is open up Fluent, then go over into geometry and change it from 3D to 2D, and then right click and do new design model geometry and wait for that to load. Okay, now that we got loaded back in, we're going to go to the Z-axis and make sure we're in the XY plane. That looks good. Next thing we got to do is go over to sketching, and we are going to do a circle, and we want to make sure to center it on the origin. So we're going to click right there. All right, that looks good. Next thing we need to do is go and take a rectangle and put that around that because that's going to be helpful for later on. Next, we are going to go over to constraints, and we want to make sure that the top and bottom of the rectangle are symmetrical over the x-axis. And then we want to make sure as well that our cylinder has a diameter of 1 meter. That's perfect. Then next we can resize our rectangle. We're going to do that one and that one. And we're going to make the length 15 meters. And we are going to make the height 10 meters. From there, we are going to add another line because we want to make sure that we have 5 meters behind the y-axis and 10 meters past it, which looks pretty good already. So we're just make that 5. Perfect. So that looks pretty good. And then from there, we're going to go concept. Modeling, and then concept, and then surface from sketches, and make sure XY plane. We're going to choose sketch 1, and then we're going to click apply. From there, we're going to generate, and that looks good. It's exactly what you expect. And then it's a little bit harder, but we're going to go and make sure we're still in the XY plane. We're going to create a new sketch. Then we go back to sketching, and we are going to choose a rectangle and make a square around our cylinder, so that way when we're doing meshing that you get a really fine mesh right there so you can see what's going on. Let's zoom in a little bit here, and we just want to make sure that everything is symmetric, so we're going to click that one as well as the top one and the bottom, and then we are going to do symmetric again and click the y-axis and the left line and the right line. Perfect. Next, we are going to go to dimensions, and we are going to make the height and the width. I'll make this a square. So we want this one to be 2 meters. And we want this one to be 2 meters as well. And, okay, and 2 meters. Perfect. That looks good. Next thing we're going to do is go over to drawing. And we're going to choose lines. And we're going to put in a bunch of lines which are going to be useful for the meshing later. So we're going to do this one. And we're going to do this one, and then we're going to do this one, this one, this one, this one, this one, and then finally we're going to do that one. Next, we have to choose we're going to do an X through the middle. And then we are going to just come over to modify, and we're just going to just trim off these extra bits. That way everything is flush with our current rectangle. Good, perfect, exactly what you want. Next, we have to go over to tools, and we're going to use a face. Where's that? Face split, perfect. And then we're going to choose our original one. We're going to click apply, and then we are going to click tool geometry, and we're going to select edges, and we're just going to go through and select all of our lines. Actually, I have to press Control and select all of the lines. So click that one, that one, that one, that one. I'm just going to go through and select all of these. Okay, now all of those are selected. Click apply, and that looks pretty good. From there, we're going to click generate, and then we are going to click on the faces, and that way we can just see that everything is selected in the way it's supposed to be. So that all looks great. From there, we are going to go out of this and click on geometry, and we just want to update everything and make sure that we get that check mark still, showing that everything's good. And we can close out of that now, and we can open up the mesh. I'm gonna wait for that to load. Okay, perfect. Now that we're in here, we're gonna right click, insert, and we're gonna do a face meshing. And we are going to just select all of these boxes and all the different faces that we have. Perfect. Click apply. And then from there, we're going to generate. Good. So we have a mesh, but still got stuff we got to do because it's not very fine right now. So we're going to right click, insert, and then we're going to do sizing, and we're going to make sure we're on edges. We're going to click that one, that one, that one, and that one. Perfect. I'm going to click apply on those. We want to make sure that we are in number of divisions. We're going to set this to 30. And then we are going to capture curvature. No. We want to make sure our behavior type is hard. And then we want to make sure that our bias is set to the first one, so that way you have it getting and we're going to set this bias factor to 4, and then we do want to reverse the bias for these bottom 3 because we want it to get finer as we get closer to that cylinder. So now that should be good for that part, and we can generate that. And then we can right click on the mesh, or go back to the mesh, and then see that it's updated some. But we're going to go back into this, insert, sizing again, and we're going to choose all of these. And click apply. And then from there, we're going to click on element type, change the number of divisions, Number of divisions, we're going to set this one to 100. And then we are going to capture curvature, no. Behavior type, hard. And then should be good. Don't need anything else really for this one. You can see our lines over there. We can click generate. After I get done generating, now we can go back. I actually do want to update this a little bit. I had it at 30, but I'm going to make it 45 just so it's a little bit finer. And then I'm going to generate that. So gonna go look at our mesh and make sure, see everything's actually looking pretty good right now. Looks pretty fine. So gonna go right click, insert, sizing again. I want to make sure that we just choose all of these top ones and the bottom ones. And then we're gonna click apply. From there, same thing, number of divisions, capture curvature, no. Behavior type, hard. And then number of divisions, we're going to set this one to 30. And then from there, we can just go and generate once again. And we can take a look back at our mesh and see that it's starting to get really good. So we're going to go back over here to sizing. And we're going to choose these ones. Click control. And then select all the ones that we need. And then apply. And then kind of what we've been doing. So we're going to change it to number of divisions. We're going to make this one 40. Capture curvature, no. And behavior type, hard. And then we're going to come over here and generate that. And take a look at our mesh. And we're going to insert one more sizing, I believe. And then we're going to click all of these. I click apply. Alright, and then we're going to change this element size to number of divisions. Number of divisions we're going to set to 40 as well. And then we're going to capture curvature, no. And then behavior type, hard. From there, we are going to click generate. And then we go take a look at our mesh. We're going to do insert, sizing, and then we just have to do these last lines here. Click apply. Same thing, number of divisions. Set this one to 40 as well. Capture curvature, no. Behavior type, hard. And no bias. And generate. There you go. You see we have a really fine mesh around the opening, so you can really see that pattern and what's going on there. And then I just want to come back into the edge sizing 4 here real fast. I'm going to change this number of divisions from 40 to 50, because I just want to make it a little bit finer. I just want to make sure that we have a good mesh going before we get into it. Okay, it's updated, and there you go. Now you see our mesh. That should be hopefully pretty good. Next, we're going to go and name like we have done in the other projects. We're just going to click N, and we're going to call this our inlet. Then we're going to click OK. And then we're going to click on this side, click N, and we're going to call this our outlet. Next, we're going to select the interior here, and we're going to click N, and we're going to call these our wall. Finally, we're going to select this top and the bottom, and we're just going to click N, and we're going to call this our symmetry. And then we're going to click OK. Next, we'll go here, make sure that we have all of our name suggestions, and that's looking pretty good. We can go out of here, update our mesh, and make sure that we get the check mark of approval. Perfect. Finally, we can click on Setup, and then we are going to click Double Precision, Solver Processes 2, and Start. And we're going to wait for that to load. Perfect. Now that we have everything loaded in, you can see our mesh and everything. It looks good. We're going to go here, click on Viscous. And for our first one, we're going to choose Inviscid, and we're going to click OK. Next, we're going to go over to our boundary conditions. And as per the instructions, we're going to click on the inlet, open that up. We're going to set our velocity magnitude to 5 meters per second. Click apply. All right, that should be good. Now we're going to close this out. And we are going to open the wall. So I'll make sure that it's just stationary, but it does not appear to be opening up at the time, but I think everything looks good. So we're just going to close that out. And then next, we're going to go over to monitors and open up residuals. And we just want to make sure that our residuals are a little more, exact. We're going to add a 0 to these. Click OK. And then next, we are going to run our calculations. So we get started with this. I think we're going to do 800 number of divisions, and we're going to calculate. Then yes, we want to initialize this before we calculate it. And we're going to wait for that to run. And when it's done running, I will get back. Okay, perfect. Our calculation is complete. So now we can go into our graphics. And first we're going to go look at the vectors for our velocity. We're going to look at the inlet, the outlet, the whole thing. Do this. And then slave display. And here we go. We can see that displayed. You get to see that those arrows showing the direction flow of everything. And it looks pretty good. You see nice wake region and everything. And yeah, so I think from there we can now close this out. And we can open up our contours and show you the velocity contour as well. Choose everything once again and save display. I'm going to zoom out a little bit. And yeah, so you can see have that really fine meshing of everything, and you see good wake region of what's going on. Next, we're going to go look at our pressure ones. So we're going to start with static pressure. That is our static pressure contour. And then we're going to click do dynamic pressure. Save display. You can see that right there. And then finally, I'll click on this and look at our total pressure. And you see our total pressure as well. Next thing we have to do is close this out. And we're going to go into plots. And then we're going to do an XY plot. Open this up. And we're going to change this to velocity magnitude. And then we want this on the wall. You can see right here we have a nice velocity magnitude of that, what's going on that wall or our cylinder. From there, we're going to change this to pressure. And we're going to take a look at our, change this to pressure. And we're going to take a look at our pressure coefficient on the wall as well. So save plot, and perfect. That looks great. From there, we're going to close this out. And then we just have to go and go to reports, forces. And then from here, we're going to click on the wall. And this kind of gives us our whole idea, shows us our total force, total pressure in newtons, coefficient pressure, everything, and you can use that to figure out your drag coefficient and everything. So that should be it for this one, I believe. So going to close everything out here now. So we get back to, okay, that just shut down. So we're just going to open this back up again. Going to, should be good. And we're going to come back when that loads back in. Perfect, get everything loaded back in again. Now, since we have to do the next one, we're going to change this from inviscid to laminar. And so that way we're under that critical Reynolds number for turbulent. We're going to go into the inlet. And we're going to change this from 5 meters per second to 2 meters per second. And click apply. And then close that out. And we can initialize and calculate. And then we get going again. So wait for that to get done. And now that that's all done, we can go back into our vector plot, and we're going to kind of do all of the same things. Going to go and select everything as well and save display. And you can kind of see that wake region going on there and with all the vectors and everything. Next, we can close this out and go back to our contours. And then we'll open that back up. And we are going to go into our velocity and click and select everything again. Look for the same display, and you can see our contours for velocity and magnitude. Next, we can zoom out a little bit, and we're going to change this from velocity to pressure. And we can start with static pressure. Save display. And you see our static pressure. Next, we're going to change this to dynamic pressure. Move this over. Save display. And there you go. See that region again. And total pressure. And that's what that all looks like. Next, we close this out. Perfect, that's all closed. Go into the plots, XY plot. And we can plot it against the wall. And ends up being 0 because the slip condition on the boundary layer, since we're dealing with the laminar, and then our pressure coefficient, and save slash plot, and we get that right there. So that looks good. And we close that out. From there, we can go to, where is that? We can go to reports. Perfect. Right here, we're going to go back into forces. And we're going to look at the forces on the wall as well for the 2 meters per second. And you can see all our numbers again, which we can use to calculate everything that I said before. Next, I'm going to close this out. And we're going to go back up here, and we're going to change this from viscous laminar over to K epsilon. And there's a lot of options. We're going to keep everything the same. We'll click OK. And then we can go over to the inlet, and that's what we are going to change again because we want this to be turbulent. So we already know that it was going to be that before with the 2 meters. So we're going to change this to 15 meters per second, which it should be plenty turbulent for us to see. Same thing, initialize to calculate, and we'll wait for that to get done. Okay, and then now we go back over, same process, go back over to the vectors. We're going to click all of them, save display, and you can see our clear wake region here. Everything's moving a lot faster, obviously. And next, just take screenshots of those. We're going to come over here, close this, and go to contours. We're going to look all the same ones from last time. Start with the velocity one, save display. There you go. You can see that nice and good. And then we're going to change this to pressure. And we're going to make that static pressure. See our static pressure graph or contour. And then we're going to change it to dynamic pressure. Save display. See that real well. And then finally our total pressure. Perfect. And then we're going to close this out. And then we're going to go into the plots again. And then we're going to do velocity. And we're going to do it on the wall, but kind of same as before. it ends up being 0 because of it. So we can close that out now. And we don't want this. Let's back up. See, it's that 0 right there. Okay, next we can do same thing, change it to pressure, and we can take a look at that pressure coefficient. And save/plot and get a nice clear graph of what that's going to look like. Close this. And then finally, we're going to go back to the forces. And we're going to print that. And same as before, you see we have a much higher number here now. But with all of that being done, I think that should be it. So after that, we should be good. So thank you again for watching. And this was Project 4.